Hello and welcome to my video about scientific notation. Scientific notation is quite important in a few different scenarios. We've got massive numbers, tiny numbers, and to show proper sig digs as we stumbled upon in our last video. So let's take a look in the massive numbers category. So we have wait, did I have that backwards? Times 10 to the negative. That should be a that should be a positive number. Otherwise, that's going to screw everything up. Okay, anyway, so massive numbers. So a chemical mole is the number of particles in a given amount of particles. So it helps us count things in chemical equations without having to actually write out massive things. So it's a unit, okay? But it's a unit that's massively massive. And we have times 10 to the 23, which means if you plug this into your calculator, and if you didn't want to write it in scientific notation form, you would have to write it out like this. Okay, now I have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that's how many particles are in a chemical mole. Now this is impractical. So that's one reason why we might have a scientific notation. And usually we don't have to use all of these extra digits because usually we have some sort of other error in our measurement where the sig digs for this other stuff doesn't matter. So fun fact, sometimes you don't need that stuff, but anywho, it's easier to write it with this times 10 to the 23 part. All right, same thing can be true about small numbers, tiny numbers like the gravitational constant, which is times 10 to the negative 11, which means that we have to go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, one more. I made a mistake. There you go. And then you can write this out. There you go. So if we were to write this out without scientific notation, again, it would be a pain in the butt. So it's easier to write it like this. So that's one reason. It's easier. Secondly, and more importantly, most of the time, is to show proper sig digs. Sometimes things are a pain in the butt and we just do them anyway, we get over ourselves. But you know, sometimes it's actually better because of a certain reason to do it, so we would keep doing it. But here, it's better to do scientific notation because it shows the proper sig digs. Shows the proper sig digs. So let's just count up our sig digs here. This is, again, if you don't remember this, watch the last video. Here we have 4 sig digs. Here we have 3 sig digs. So our final answer has to have 3 sig digs. So let's just plug this into the calculator, the trusty old calculator. 21.12 times by 132. So we get, in our calculator, 2,787.84. That's what my calculator gives me. Now, even if we round it to the nearest whole number, right here, that would still be 4 sig digs, not 3, which is what we need. So we need to turn it into scientific notation. So we put 2.79, and this is our 3 sig digs, times 10 to the 1, 2, 3. We moved the decimal 3 places, 1, 2, 3, and so that's why it's times 10 to the 3. Okay, I want you to try the next one out on your own, and then pause the video right now, try it out, and then press play once you have it. All right. Okay, so I have now plugged it into my calculator. I have 37.0015. Fantastic, that's great. Actually, no, because here we have 4 sig digs, here we have 3 sig digs. We need to have only 3 sig digs. Now, we can do it like this, and that'll be 3 sig digs. That's fine, but it's not as good as if we turned it into scientific notation. So sometimes you can actually go like this and have a 0 at the end, and that's perfectly fine as well. And this is just times 10 to the 1. So this is a less likely case. You'd probably be fine putting 37.0 because it works out. But when the number is bigger than the number of sig digs, that's when you really have problems like this one. All right, I hope this video helps you understand scientific notation a little bit better, and good luck.